Hello everyone, we continue with Milestone 4. Milestone 4 is to create a machine learning model for the text sentiment analysis or multi-class text classification. Okay, we'll prepare the environment first. As usual, we log on to the Azure portal using this credential. Okay, everyone, we need to quickly create the machine learning workspace. Okay, for the resource group, Milestone4 RG. Okay, for the machine learning workspace, we create the MLW Milestone4. Okay, the rest use the default setting. Okay, just wait for a while for the validation. Okay, then create. Now while waiting this machine learning workspace to be created, I open the tiny URL. To get the data for the experiment. Okay, we download the data set in the zip file. So we then go to the folder. We will extract this data. Okay, then we have this text data. Okay, so done already. We go back to this and then still waiting. Okay, just wait for a while until this machine learning workspace created. Okay, in the meantime, we look at the lab instructions which available here. So this similar like assignment 4 you have completed before. It's quite tedious, yeah. So need to do carefully. Okay, so basically we will have a data set that contains some text, and we're going to predict the sentiment of this text. Yeah. Okay, later we will see more detail, or in the meantime if you want to open this to understand the data better. Okay, so this is the data set. We have the text ID and then the text. Yep. Okay, so In total we have the 27,000 message, okay, and short message. After that we're going to classify the text here. So here sentiment is a neutral, negative, positive. So there are three classification, and the idea is after we create a model, then we get a new text, then this model will be able to classify whether this text is having the sentiment positive, negative, or neutral. Yeah, like for example, sick. Yeah, sick is negative. Yeah, sad, negative. Yeah, and then after that, greed. Yeah, that's positive. Excited, positive. Yeah, brutal. Yeah, negative. Bugger. Yeah, negative. I don't like. Yeah, for example, then that's negative. Okay, not well. Poor you. Yeah, not looking. Yeah, negative. And then I don't like. Yeah, negative. Okay, so something like that. Yeah, we keep this open and check the workspace. Okay, done already. Yeah. So now we're going to quickly create the compute instance. Create a new compute instance. CPU, then next the name. Yeah, provide the name. Ryan com I. Next. Okay, then next, nothing to change, create. Okay, leave this running, creating the compute instance. We go to the data, so we're going to upload the data. Okay, register the text dataset, create, and then after that under the asset name we going to create the sentiments table. Okay, then just copy this in the description. Then the type is tabular. Next, you're going to copy from the local file. Next, after that use the default blob storage. Okay, next, after that upload the file. Okay, in the download dataset, yeah, this one. Okay, wait for a while. And then click next. Yeah. Okay, so here the encoding is ISO. Yeah. Okay, by default. Yeah. So so keep the ISO format. Yeah. Do not change to UTF-8 because if you change, then you will have some problem. Yeah. So keep the ISO 8859. Do not change. Yeah. Okay. Do not change. I modify the instruction. Thanks to cache that highlighting this issue. If you change this to UTF-8, then you will have problem. Okay, so if you have a problem, yeah, changing this, then because of the data format, yeah, so we do not change, but we keep the ISO. Okay, click next. Then after that, the rest is just a default. Okay, now we have created the data set. So you go to the okay. So go to the designer. Then we're going to create the pipeline. Okay, I already have changed the manual, the instruction guide. So I put here. Ensure the coding is set to the ISO this one format. Okay, yeah, do not change to the UTF-8. Okay, yep. So create a new pipeline. Then drag the sentiments table. Okay, before we move to the next step, let me preview first what the data that we have. Yep, here you go. Then after that, choose the profile in the sentiment. Yeah, so we have the almost equal. Yeah? Neutral and then positive. That's neutral about 4,000. This is about 3,000. Then negative is about 2,799. Yeah, 4,000, 3,000, and then 2,799. So more or less are almost the same lah. Yeah, this one is a little bit bigger. This one is a lesser. Okay. Yeah, I think just now because we have this, yeah, some character, yeah, then need to change the format, yeah, into the ISO. The others like land density, yeah, we don't need that. Yeah, country we don't need. Yeah. So we only need the text and also the sentiment. So the text is like this. Yeah. Okay, so we already browse the data, more or less we understand. Now we build the pipeline. The first after we drag the data is to rename the pipeline to the sentiment analysis pipeline. Okay, then save it. Yeah. After that, we're going to drag the select column from the component. Okay, select column. Then in the column, you're going to choose only okay, something wrong. Confirm. Okay, let's open again. Seldom we have this, but today we have this error. Ah, okay. Yep. Failed to fetch dynamically imported module. This one. Okay. Something wrong. Okay. So let's open again. Why? This is a sentiment table. Okay. Component. Select column. Try again. Okay. Did I choose wrongly just now? The select column transform. Okay. So right click. Edit. Not name. Okay. Just save it first. Then double click. Okay. Okay, everyone, interesting. Yeah, we never have this kind of problem before. Okay, try again. Okay. Try again is okay. Must save first. Yeah, must save first. If you have problem this, you have to save first. Okay, so the column name is selected text, and then the sentiment. These two only. Okay, then the rest is the default. Don't forget save and then close every time you change. Then pre-process text. Okay, follow the language English, expand verb contractions true, remove stop words true, use lemmatization true, and then remove numbers, special characters, URL. Okay, it is true. Yeah. Set the text column to clean as selected text. Okay, this one. Change to the selected text. Okay, yeah, so save it. And to check, you can compare with the picture screenshot in the lab guide. Okay, just to verify one more time, let me check the from beginning. English true, 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 all true. Custom regular expression we don't have. Custom replacement string we also don't have. Then column name is selected text. Okay, good. Yep, then don't forget to save, then close. After that, add the split data. Yep. Okay, how many percent? 50, 50. And then split the row. Randomize is true and stratified is based on sentiment. Because just now we saw that the sentiment is a little bit imbalanced. Yeah, 4,000 for the positive. Yeah, sentiment based on the sentiment. Save it. So this will be proportional. Okay, so this done. we can arrange a bit. Yep, okay. So the data preparation is done. Save it. Yeah. Now I will make it smaller a bit. Then we're going to drag the n-gram. We use the n-gram. So we do it twice. First, we configure the first one first. So in the first one, we set the vocabulary model to create, because we don't have the vocab now. We create first, and the second one we create the vocab to read only for the testing data. So the n-gram is configured to have the 2 gram. After that, the TF-IDF, then maximum 3, minimum 3, maximum 25. Normalize is true. Okay. Yep. So this is the first one. Then save it. Then close. So we're going to copy this to create the second one. For the second one, we change the read only. Okay, the rest are the same. Okay, then we link from the split data. Okay, split data. The result, the data set is going to the first n-gram. Okay, then after that, this will be going to the result vocabulary. Go to the input vocabulary, and the result data set is go to the data set. Yep, here you go. Yeah. Okay, after that, then we're going to configure the column, yeah, in this one. Yeah, edit the column. The column name is pre-process selected text. Okay, yeah, pre-process selected text. Careful, guys. Yeah, a bit tedious. No typo error. Okay, click save. Okay, just cross-check. Pre-process create 2 TF-IDF, 3, 25, 5, and then 1. True. Okay, good. Yeah. Then the second one. Same column. Save it. Okay, the rest is the same. Yeah, then ready. We save it. We're going to prepare for the algorithm and training the model. So here we just choose one, logistic regression, multi-class logistic regression, this one. Okay, after that connect training dataset from the first extract n-gram features from the text module to select column in the dataset module. Okay, so we need to add the select column. This one just now we got an error, yeah, so have to be careful. Save first. So connect the training dataset from the first extract, yeah, this one, to the select column. Okay, here. Then after that, the select column should be configured as a with save first. Yep, the edit column. The selected text and then pre-process selected text. Okay. Yep. Okay, so the rest is all the same. And then in the select column, selected text, pre-process selected text. Okay, good. Yep. And add the train model. Okay. Connect to the multi-class logistic regression model and the training data output from the select column from the dataset module. Okay, this one. Then untrain, go here. Yep. So set the sentiment and add the label column. Okay, then click save. Okay, then continue with the train the model, sentiment false. Okay, then after that score the model. Okay, so the second testing dataset from the second one, ngram, you bring this here. Okay, add the score model module and connect test dataset and train model output. Okay, good. Then evaluate. Okay, save it. Yeah, maybe we will tidy up a bit the shape to make it easier to read. Yeah. Okay, save it. Then close. No, no need to close. Okay, let me have a quick look again one more time to make sure that everything is okay, especially the below part. Train the model. Yep. Okay, train the model is here from the select column. Okay. Yep, looks like okay. So save it, and then now we're going to run this pipeline. Okay, so check the compute instance should be okay now. Configure, create an experiment name to use the existing one. No, create a new. Yeah. So AML project, the name. Display name, sentiment analysis pipeline. Okay, next, in the compute instance, we choose this one. Yeah. Then next, submit. Okay, so the job submitted. Then we going to look at here in the jobs. Yeah, sentiment analysis pipeline. Okay, everyone, this will take a while, and I just wait there. Okay, so select column done, and now is continue with the pre-processed text. Okay, now splitting the data 50-50. After split the data, then pass the 50% data for building the vocabulary. Okay, so the first step to build vocabulary already done. So in the meantime, while we are waiting, we can have a look in the preview the data. Yep, so here you go. This is the data from the 13,740 row. Okay, yeah, this is the pre-processed selected text. So you see that broke is the first word is a break, the present tense. Okay, so this is a pre-process. Okay, then the vocabulary. We have the error in the trainer model. Let's see what happened. Okay, so sentiment column with name or index sentiment not found. Okay, I think I know why. Because the instructions should be one moment, yeah. Train the model sentiment column label column. Okay, one moment. We close this. In the select column in the dataset, we need to have the sentiment. Okay, so I go to the designer. Yep. One moment, yeah. So let's have a look at here in the selected column, one moment, include, okay, sorry, I make a mistake. It should be include all column and exclude the selected text, so this one is wrong. Yeah, okay, this should be the include the all column. Yeah, okay, then this one is exclude, so include all column, then after that exclude column name, and we have this selected text and pre-processed text, so that's my mistake. Okay, so I make a correction, then save. Yeah, resubmit again. So use existing. Okay, so corrected. Yeah. Review, submit. Okay, go back to the jobs. Go to the this one is earlier. Yeah, this one's corrected. Okay, so we make changes in this selected column, select column in data set, then it will repeat after this. Okay, back to the just now, we want to preview the category, the vocabulary. Right click, preview the data vocabulary. Okay, so this is the vocabulary, the word that collected. There are total 1660. Okay, yeah, so that's the word, yeah, the vocabulary. Okay, looks like now going to be okay. Yeah, okay, trend model finished already. Now is continuing with scoring the model. Okay, wait for a while. Okay, everyone, you would like to know what the data is passed into this for the training. You can review, preview. Yeah, this is the data set that sent for the training the model. Okay, so pre-processed text. Yeah, this is the word by word. There are total 1660. This is what we call as a pack of words. Yeah? So its word vocabulary is okay. My lab time is need to extend. I need to extend. Okay. Yep. So this will generate the column number based on the vocabulary. Yeah, 1660. That's now the vocabulary 1660. Yeah. So if I ask you a question, yeah, how many columns generated in the training dataset for the n-gram. Yeah, it is the same number column as the vocabulary. Okay. Yeah, so done already. Evaluate the model, then right click, then preview the data. Okay, so here how to interpret this. So you know the difference between micro and macro. Yeah. Okay, so micro is overall, yeah, but macro is per class. And yes, so overall is 0.78 or close to the 0.8, which is quite okay. Yeah. And then how this result distributed. Okay, wait for a while. The page is not responding. Yeah, wait for a while. Okay, so if you remember last time when you did the uh, the two class classifications, we have the predicted and actual. Yeah, so we have the true positive, then false true negative, and then false positive, and then false negative. Yeah, this one is only for the binary. Binary meaning two classes. Yeah. But here we have three class. Yeah, the positive, neutral, and negative. So we have a 3 times 3 matrix like this. Okay, yeah, so this is the true positive for okay, so the this one can be seen here in the view the log. Yeah. After that expand, then after that we go to the matrix. Okay, yeah, so we have the macro precision. Okay, then let's have a look matrix. Yeah. Yep, overall accuracy. And then in the images, do we have? Yeah, okay. This one. Yep, so this is the confusion matrix. This one is the negative, neutral, positive. Yeah. So what? How to interpret? Yeah. So the actual text, sentiment, which is done manually, is negative, and then the model predict correctly. Okay, so 76%. And the text sentiment is neutral as per manual classification, and the model predicted correct. Yeah, 81%. This is the highest. And the text sentiment is positive, and your model also predict correctly. Yeah. So average is about 78%. Okay, 76, 76, 81. Average about 80%. How about this one? Yeah. So this one is the actual sentiment is negative, but your model predict as neutral. Okay. And this one, the actual is negative, but your model predict as positive. Yeah, this is not very good. Yeah, because if negative, then predict as neutral, not very bad. Yeah, but if a negative predicted as positive, then this is worse. Yeah. Then neutral predicted as negative 12. Yeah, 0.5. Neutral predicted as positive 6. Yeah, this one is not bad. Yeah, 12 and 6. Positive predicted as negative. This one is bad. Yeah, this one is bad. Yeah. Okay. And this one neutral. Actual is positive and then predicted as a neutral. Okay, so this is all wrong. Yeah, the blue one is the correct. Yeah, the blue one is the correct. So the correct prediction. And then average is about 78%. Okay, yeah. So that's how to interpret. So the usage is if there is a news like I think that about Twitter message. Yeah, Twitter message come and normally in the past we did the manual sentiment classification. Yeah, okay. So we received an okay, positive, negative, positive, negative. But your machine learning model will be able to help you with the accuracy up to the 78%. Okay. So that's the this one. Yeah. Okay. Actually, there is one tab explanation which is the can be populated. Yeah. But if you choose and now we play around because the actual experiment already completed, then I go back to the designer. I try to check if I can produce that explanation in the train model. Now this one model explanation. Yeah, click whether to generate explanation for the train model. Default is unchecked to reduce the extra compute overhead. Yeah, okay. So we choose the true. Then save. After that we submit. Yeah. Okay. Job display name. Yeah. Try to add with the explanation. Okay, then review, submit, submit. Okay, so go back to the jobs, go to the ML project. This one that failed, you can delete if you don't want to confuse. Yes, yeah, then delete. Okay, yep, so this one we didn't change the other process, only change in the model. Yeah, train the model. This one, so retrain again. Okay, wait a while. In the meantime, let's see if we create the data set. Yeah, if we change to UTF-8. Yeah, we want to produce whether get an error or not. Yeah, go to the data. After that, we going to import again sentiments table. Yeah, so add data set. After that, sentiments table UTF-8. Yeah, like this. Okay, from the local file. Next, next, upload the file, text data. Okay, then next, Okay, so we change to the UTF-8. Yeah, unable to preview. Yeah, okay, so you see pre-processing the provided file have invalid bytes for the specified file encoding. You can still use this setting, selecting the skip data validation, but the data will not be read, which also means no preview or schema. Okay, so this one is what Cash mentioned to me in his message, and I took note, and I have already amended the lab instruction. Okay, here you go. Yeah, so in the Milestone4 I put here this one, this one. Yeah, ensure the encoding is ISO, do not change to UTF-8. Yeah, okay. Okay, so that's the, we don't need to continue. Yeah, so leave. Okay, we go back to the jobs, then check the current jobs, train the model. Okay, yes, so train the model already finished, completed. Yeah, then okay, now evaluating. In the meantime, let's right click and then view the log, expand, and then explanation. Okay, so we have something here, the explanation of the train model. Still loading. Okay, yep, so here we have some model performance. Yeah, okay, all data negative, neutral. So this one is just now you see that the neutral is 81%, right? Yeah, then this one is about 76. Okay, so this is the how many row that the model perform correctly. Yeah, with this 251 data point. Okay, dataset explorer. Okay, pre-process selected text. This is the box plot. Yeah. Okay, not much individual data point. Okay, this is a box plot showing the negative, neutral, positive. Yeah, the index data from the 250 data point. So only sample. Yeah. After that, fairness. Yeah, preview. No monitoring. Okay, this one is a resource consumption. Not much thing. Okay, metrics. Nothing. Jobs. Yeah. Okay. Okay, so yeah, that's the additional thing that you can get from the enabling the explanation, the preview. Okay, let's close. How about this one? In the evaluate model, when you open the log, do you have any other informations? Let's open. No, yeah, nothing. Okay, if you want, you can also do similar like last time, yeah, when we did the assignment 4, to compare with the feature hashing. But looks like this is not bad already. Yeah, 80%, 78%, yeah, close to 80% can predict correctly. Okay, yeah, that's the how to interpret this data. Yeah, so this one is to predict the multi-class classification. So negative, and then neutral, and then positive. This is the actual, and this is the predicted. Okay, so just now this one was about 76%. This is 81%. This is 76%. And the best is when it is neutral. This is the negative. Okay, yeah. Multi-class classification. If the class is more than 3, then the matrix become bigger, then more complicated. Yeah. So this one is 2 times 2. Yeah. This one is the positive, and then after that negative, and then this one is the positive and negative. So this is a true positive, yeah, true negative, and then this is the predictive. Yeah. So this one is a false negative. Oh, sorry, this one's negative. Okay, this one is a false negative. This is false positive because this is a P and then negative. Yeah. So false positive is below. Yeah. Okay. Yep. So that's conclude the milestone 4. So after this, then we can take the screenshot, then can take some uh, questions or answer, or take a break. Yeah. Okay, let me close this first.